Alright, so here we're converting from form to form. So we know transformation form is AH and K, so we're taking A, H, and K form, and we're converting it to the new form, which is standard quotient form, which is AX plus B over CX plus D. So this one, if you think about it, this one's like a mixed number, a mixed fraction. This one is like your improper fraction. So I'm going to kind of review with the mixed number how to get an improper fraction. That's basically the same thing we're going to do. Okay, so back in whatever elementary school, here, if I wanted to add these to the fraction and the whole number, we write it as 3 and 3/4. So this would be your mixed number form. That's essentially what this form is right here. So think about how to convert this to an improper fraction. So the trick is you take the denominator and you multiply it by the whole number. So here I would get 12, and then I would add the numerator. So 12 plus 3 is 15, and then the denominator stays the 4. So here, this fraction, this improper fraction, is the same thing as 15/4. Okay, technically what you're doing is you're making common denominators and then you're multiplying to add them together. But this is the shortcut. I don't know, some people have called it Texas, some people call it smiley face, whatever you call it. I mean, basically you're just doing common denominators. Okay, so that's the same thing we're going to do over here, except I'm not going to move it and write it like this. I'm going to take this number and I'm going to multiply it to this one, and then I'm going to add it to this one. So take your K value and multiply it to the denominator. Now when you do that, make sure you distribute it to both. So here when I distribute it to X, I get 3X, and I distribute it to the 4 plus 12. So you multiply to the denominator, that's this part, but then you have to add the numerator. So I add 3 to that. Okay, so the numerator is going to be 3x plus 15. And then what did we say about the denominator over here? It stayed the same, so all along this is just going to stay x plus 4, x plus 4. Okay, so in either case, the asymptotes, we really don't need to convert to get the asymptotes, but to convert, we do need the intercepts. Or to get the intercepts, we do need to convert. So remember the vertical asymptote? In either form is the denominator. So here the x plus 4, here the x plus 4, tells us that the vertical is at -4. The horizontal, it depends what form you're looking at. The horizontal in this form is the K value, so y equals 3. In this form, we're going to see that it's the numbers in the front. So 3 divided by 1 is 3. Oh, we don't know that yet, but we'll see it soon. Okay, and then for the x-intercepts, that's going to be the numerator equal to 0. And we solve for x. So set this part equal to 0 and solve for x. 3x plus 15 equals 0. If I subtract 15, I get -15. I divide by 3. X is -5. So -5, 0 is your x-intercept. So x-intercept. And then finally the y-intercept are the ratio of your constants. So y-intercept are the constants here. So y equals 15 over 4, which can't reduce, and if you want to change it to a mixed number, you can. It's this number over here. I'm just going to leave it as 15/4. You can change it to decimal too. I don't care how you write it. Just make sure you do write it as a coordinate. Okay, so to go from transformation to standard, transformation to quotient form, you change a mixed number to an improper fraction. Multiply and add to get it. To go backwards, you divide. So, come on. Here's some examples. You can work through those. I just want to make sure we get through the converting part. Okay, so this one goes backwards. It gives you standard form here, standard quotient form, and it wants you to find transformation form. Okay, so this one we did this year. To change an improper fraction to a mixed number, you divide. So here we're going to do long division or short division, whichever one you want. So we're going to put the numerator inside, 3x plus 8, and we put the denominator outside, plus 2. So if you remember the long division, you ask yourself how many times does x go into 3x? X times 3 is 3x. So then you multiply 3x by both of these. 3 times x is 3x. 3 times 2 is 6. But this is the tricky part. You have to remember to subtract these. When you subtract, you're subtracting both. So basically you're distributing the negative. So the negative goes with this one and with this one. And then you just add them. So 3x minus 3x cancels out. 8 minus 6 is 2. So here's where you have to be careful, because we always forget to do the opposite. Okay, so technically what we're doing here, if you want to think about 38 divided by 12, which is essentially what this is when you plug in 10. So we did how many times does 12 go into 38? It goes into it 3 times. Oops, wrong color. So 3 times. And then we took 3 and we multiplied it by this, and we got 36. And then we subtracted to get 2. So subtract these and we get 2. So now if you think about it, how do we write this as a mixed number? The whole number part is this one. So we're going to do 3 is the whole number part. The remainder is the numerator. So this is the remainder. And the denominator stayed 12. So the denominator stays 12. Now here, yes, you can reduce that to 1/6, but we're not going to be able to reduce over here. I just want to show you how it relates to regular dividing. So 3 is the whole number part, which it's your k, and we don't write the k in front. We write the k at the end. So it's going to be a plus 3 at the end. 2 is the remainder, which is your a. And then the denominator stays the same, which is x plus 2. So y, well, okay, in this case r of x, but y equals this transformation form. Okay, so you can divide your polynomials. You can use synthetic division, but I mean it's not that long of a process. So it's not long division, it's really short division. If you want to use synthetic division, you can, but like I said, it's only going to be one step. It's not going to be a very long synthetic division. Okay, so real quick, I'll go ahead and just show you one of these. I'll go ahead and work all the examples out. If you're good right there, you don't need to see the rest, but I'm going to go ahead and work out example number 9, and I'll come back and work out these up here. Okay, so looking at 9, we're going to do negative 2x plus 2 on the inside, x minus 5 on the outside. So x times what is negative 2x? X times negative 2. So then we multiply negative 2 by both of these. Negative 2 times x is negative 2x. Negative 2 times negative 5 is positive 10. This is where you have to be careful. You're going to subtract both of these. So when you subtract, remember you distribute it and you change the sign. So this is going to become positive and this is going to become negative. And then you just add them together. So negative 2 plus 2 cancels. 2 minus 10 is negative 8. So in transformation form, remember do A, H, and K. The minus 2 is your K. That goes out here, minus 2. The remainder is your A. So this is the remainder. That's going to go up here. And the denominator stays the same. So x minus 5. Okay, you can go back and do the asymptotes and the intercepts. I want to do the process. So for B, divide 4x minus 1 by x minus 6. Okay, so how many times does x go into 4x? It goes into it 4 times. 4 times x is 4x. 4 times negative 6 is negative 24. So then be careful here when you subtract both of these. Minus this one plus this one. And then we add them together. So 4x minus 4x cancels. 1 plus 24, negative 1 plus 24 is 23. So writing it in transformation form, the plus 4 up here is the k value. The 23 is the a value. And the x minus 6 stays the same. Okay, so then just real quick, vertical is the denominator, 5, horizontal, and that's also down here, 5. Horizontal is the k value on the outside, or the coefficients in the front, however you want to think of it. Negative 2 over 1 is just negative 2, and that's what this says over here. X-intercept, numerator equal to 0. So if I set this equal to 0, negative 2x plus 2 equal to 0, I'm going to get a negative 2 divided by negative 2. Negative 2 divided by negative 2 is just 1. And then the y-intercepts are your constants. So 2 over negative 5 is just negative 2 over 5. Again, you can change that to decimal if you want, but not all the decimals are going to be nice, so I'm just going to leave it. Okay, over here, vertical asymptote, denominator equal to 0, denominator equal to 0, be 6. Horizontal asymptote, outside number, constants, or sorry, coefficients is 4. So see the k value or the ratio of your coefficients. The x-intercept is the numerator equal to 0. So here if I set this equal to 0, plus 1 divided by 4 is 1/4. And the constants, negative 1 over negative 6 is positive 1/6. Okay, I'm not always going to have you identify, I'll have you do one or the other. Convert it or identify the critical values. Okay, this is just review. Alright, so again, that's going from quotient to transformation. Back over here is the transformation to quotient. I just want to make sure you understand how to do the process. So this is the multiply and then add. So you're going to take this, you're going to multiply it, and then add this one. So multiply 3 times the denominator is 3x plus 15. But then I'm going to add the negative 2, which essentially is subtracting in this case. So here I get 3x, 15 minus 2 is 13. And the denominator stays the same, x plus 5. X plus 5. So here's your standard quotient form. And we'll come back for the intercepts and the asymptotes. Okay, same thing over here. Take negative 6 and distribute it. Negative 6 times x is negative 6x. Negative 6 times negative 3 is positive 18. But then we have to add the 2 on the top. So multiply and then add. Denominator stays the same, x minus 3. So here, negative 6x plus 20 over x minus 3. Alright, so just to review one more time, vertical asymptotes are x equals, it's either this one, h value, or the denominator here, negative 5. I'll go ahead and do over here, vertical asymptote, denominator, 3. Horizontal asymptote, y equals, it's the k value in transformation form, it's the coefficients in quotient form. So 3 over 1 is 3, and that's what the k is. Negative 6 in this form, or constants in this form, negative 6 over 1. So again, you can do that one in either case, it doesn't matter. The intercepts, though, you need quotient form. So for this one, you set the numerator equal to 0 and solve. So here I would get negative 13 divided by 3. Negative 13 divided by 3 doesn't reduce, so I just leave it 0. Here, set this equal to 0. I'm going to get negative 20 over negative 6. Negative 20 over negative 6. This one does reduce. So dividing it by 2 makes it 10 over 3. Divide by 2, and just 0. And then finally, your constants are your y-intercepts. So 13 over 5. And then over here, 20 over negative 3, so negative 20 thirds. If you want to change it to mixed number, go ahead. I'm just going to leave it like that. Just make sure you reduce them. Okay, so that's the final thing in simple rationals, being able to graph them in either form and identify the critical values, and then being able to go from one form to the other.